If we want to evaluate a derivative at a given point using implicit differentiation, the only way it differs from what you've been doing so far is that you'll have to plug in not only an x, but also an y. When I look at this problem, y squared equals the quantity 2x squared minus 3 divided by the quantity x cubed plus 1. I'm looking at a quotient rule. However, I'm not going to use a quotient rule with this because this would be a huge, nasty problem. So I think it might be simpler if we just multiply both sides by the x cubed plus 1. So if I multiply by x cubed plus 1, it will go away here. And x cubed plus 1. Here I'm going to distribute that y. So I'll get x cubed y squared plus y squared equals 2x squared minus 3. I think that might be easier to take the derivative of. So the first one, this x cubed y squared, is a product rule. So we're going to take, we'll write down the first, take the derivative of y squared, which is 2y dy dx, plus the second derivative of the first, x cubed, is going to be 3x squared. Okay, plus, take the derivative of y squared, that's going to be 2y dy dx, and then that's going to equal, taking the derivative of 2x squared is normal, so that becomes 4x, and then the constant is going to be 0. All right, now I want to group my dy dx's together so I can solve for them. By the way, you can plug the 0, negative 3, this point right here. You can plug it in at any point you want to. You can plug it in now, or you can solve for dy dx and then plug in the point. I'm going to wait. I'm going to go ahead and solve for the dy dx, and then we'll plug in the point afterwards. All right, so now we have, getting these two guys together, x cubed. Well, put the 2 out front, 2x cubed y dy dx plus 2y dy dx. Okay, and I'm going to subtract this y squared, 3x squared from both sides. So it's negative y squared 3 and x squared. And of course, we're going to rearrange that. So we get 4x minus, and that will become 3x squared y squared. Now I'm going to factor out of dy dx. And we have 2x cubed y plus 2y equals 4x minus 3x squared y squared. And then divide both sides by the 2x cubed y plus 2y. Dy dx equals 4x minus 3x squared y squared all over 2x cubed y plus 2y. Okay, so the point is 0, negative 3. So in for my x is 0, in for my y is the negative 3. So this equals 4 times 0 is 0, minus 3, x is going to be 0, and then times the negative 3 squared. So that's going to be 0 as well. And that's over. The x is going to be 0, so it's 0, plus 2y, so that's 2 times negative 3. All right, you may have said, well, as soon as we got 0 minus 0 on top, we're going to say that the slope is 0. However, you've got to make sure that the bottom doesn't also equal 0. Because if the bottom had also equaled 0, I would have said that the slope was actually undefined. So this is actually 0 over negative 6. So the slope of the tangent line at the point 0, negative 3 is 0.